Today we have the final demonstrator event for this large project called Pipebots, where we're developing robotic technologies for water pipe and other pipe networks, buried pipe utilities. And we're demonstrating everything that we've done in the last 5 years in terms of developing different types of robotic technologies, different types of sensor technologies, different types of communication technologies, all for pipe inspection and pipe navigation and robot localization in real pipes.
The primary research is to prove the concept that we can go into pipes with these small robots. They can move through the system, they can report in the way that they want to. They can live in the system, they can charge, go navigate the system by themselves. And that then leads to a far more effective, far more sustainable, far more resilient wastewater and ultimately buried infrastructure set of services so society can operate in a far more undisrupted manner.
It's going well, so our industry partners like what demonstrating them. They can see clear relevance to what they're doing and the relevance to the problems they're trying to solve and the challenges what the industry faces in general.
And it's been really interesting to see all of those robots working, being demonstrated in different environments, and they've managed to explain very well about all the advances they managed to make in different areas of their research.
One of the reasons why industry doesn't use autonomous robots is because they get stuck, they break. And we don't want our pipe networks to be stuffed with broken robots. And this really highlights the fundamental problems and where we can try and work with industry. They bring the expertise because they already operate robots in networks. They understand the pipe infrastructure. They understand the challenges and the regulations, whereas we have the out-of-the-box solutions and some of the basic research. We can bring in the different disciplines, people from civil engineering, from mechanical engineering, from electronic engineering, from AI and control, and even people working on natural intelligence systems to bring some out-of-the-box inspiration and bring all of those together and work with industry.
Autonomous robots are really difficult because, well, for many reasons, but it mostly combines like the three aspects, which is like mechanical, electronics, and software. To get everything right, it's really like this jigsaw puzzle. Like you need to have all the bits and pieces fitting together.
Powering themselves, we need them to be navigating themselves, we need them to inspect, decide, maybe in the long term repair. That all introduces lots and lots of very fundamental research questions, as well as very practical ones. And on top of that, regulation ones in terms of what is safe to have in your water pipes.
Water utilities themselves don't do much R&D. So they normally buy in technology which exists off the shelf. They do a little bit, but not that much. So therefore developing solutions which are radical, which change the way they operate, is very important to make sure that the industry become resilient, moving towards net zero, and provide all of us with clean and safe water.
And I think one of the strengths that the program's really had is they've managed to engage really well with industrial partners on the project, particularly the water and utilities companies, who are ultimately going to be the adopters of the technology. But also they've managed to engage with the public as well, through public lectures and social media, to really ensure that the public understand the value of the technologies that they're going to be offering.
So once the research then has matured, what we will be able to do is provide industry with the technology it needs to do the assessment of the condition of our buried pipes. It provides asset managers with the tools to manage their complete systems. And of course, once we've carried out this research and helped the water industry, we can then turn our attention to other industries, the gas industry, maybe repurposing gas pipes for hydrogen. There are many ways in which we might be able to take use of this, looking to the far future.
This event attracted key players in the industry, whether it's water utilities or the subcontractors who provide water utilities with the solutions. And we can see very good buy-in from these people in terms of understanding where the technology we develop can fit in the products and services they are providing already or developing in the pipeline. And that's very encouraging for us.
So I think it's really successful. I'm really proud of how far we've come. We've started from absolutely nothing. We've worked very, very closely with a whole range of end users and stakeholders in government and in the water industry. And we've managed to generate robots that can go and explore pipes autonomously without any tether, any cable, any communication with the outside world. Very little computational power, which means that they can last a long time in the pipe network. We've managed to generate robots that are waterproof and can move around in aqueous environments like water pipes. We've built interesting acoustic sensing technology that can help us localize and inspect the pipe infrastructure, and communication technologies that helps us communicate between robots, underground, and also communicate to the out of ground, to the human element of the network.
But yeah, it's really great to see how it's all coming together and it's pushing the boundary of what's possible.
I think Pipebots has brought together a real combination of great elements. Firstly, it's real novel engineering, emerging technologies, world-leading researchers, and the use of amazing facilities like this one to be able to demonstrate all their technologies and really provide that exciting vision of what this can achieve in the future.